Okay, my recording didn't quite go through the last hour, so we're going to do this. We're going to do operations with complex numbers today, and this is not very difficult. What we do today will help you do what you're going to do on Monday. On Monday, I'm not here. I'm at a funeral, okay? So I'm gone all day. But on so you're going to have a book assignment on Monday that's going to directly relate to what we do today. And it's not that difficult. But it is somewhat new, so you will have to make sure you pay attention. Complex numbers look like this. Please write this down. A plus BI. And they have two parts. The A part is the real part, and the BI part is the imaginary part. And they should always be expressed in that way. The real part first, plus the imaginary part second, and they should be broken into two terms. Okay? So, the addition subtraction go just like we think it would. So I plus 6i, anybody want to guess? 7i. Now, does true or false? I is negative 1. Right. I is the square root of negative 1. Remember, you can't take the square root of negatives and get a real number. You get imaginary numbers. So by definition, the square root of negative 1 is equal to I, which means that I squared is equal to negative 1. Now, we'll talk about multiplying later, but right now we can add imaginary portions together. I plus 6i is 7i. How about 3 plus 4 plus 6i? 7 plus 6i. I think you get the idea. Why don't you quickly do 3 through 8 right now? Why don't you stop at 8, okay? Why don't you quick work through those, see what you come up with. My birthday is a great day. It's great, trust me. And you guys are all invited. The 21st will be a Wednesday. That'll be our last day of school that week. You are more than welcome to bring gift cards, presents, you know, cash. I accept a lot of things, so anything you want to bring is fine. What? You're gonna make me cupcakes? That would be great. Phenomenal, Taylor. You're special. Okay. All right. That's very no, it's very selfish of you. Good job. All right. Number 9. If we multiply, we distribute, and watch what happens. Okay. If you take 4i times negative 2, anybody want to guess what you get? Negative 8i. But now when we do 4i times negative 8i, we get a negative 32i to the squared. Now, we can simplify I squared. Nathan, what is I squared? Negative 1, which would make that a positive 32. Question. 3i plus I should be 4i. Negative 8i minus 7i should be negative 15i. I did lie to you. This should be negative 5 minus 9i. This should be 15 plus I. This should be negative 3 plus 6i plus 5 plus 3i minus 8i. So if we gather like terms, we'd have 2 plus I. There's no multiplying there. And then here it looks like we have 3, 8, and negative 7 would make 4. And we have 3i and minus 2i, so it would be plus 1i. Question? Yep. So back to the problem we were working on. Does everybody see that this becomes a positive 32? Because I squared is negative 1. And negative 1 times 32 will be a negative 32. So it'll be a minus a negative 32, which gives you positive 32. That's I. That's an I. Excellent question. Yep. You're more than welcome to move forward if you want. What? It could say plus. Then it would be minus. If it said plus, then it would be a minus when you square the I. Negative. Yeah, negative 32. So let's try number 10. 5i times negative I would be a negative 5I squared. Now, I'll write it out here. This looks like negative 5 times, what is I squared? Negative 1, which is positive 5. No, 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 no. Shh. I is not equal to negative 1. Shh, boys and girls. I is not equal to negative 1. I squared is equal to negative 1. So look at what I did. 5 times a negative is negative 5. And I times I is I squared. That equals negative 1. Then the negatives cancel, which gives me positive 5. I is I. I. It is I. I is the square root of negative 1. Now, in every single class, somebody has brought up the point of, is I the same as negative 1? We've talked about it. It takes a while to think it through, but the best way I can bring it to your attention is this. If you simply think to yourself that you have a number line and you take the square root of 1, you can find that. You can locate it, okay? Square root of 1 is 0. I'm sorry, square root of 1 is 1. It's right there, okay? But if you take the square root of negative 1, that's I. Where do you locate that? You can't. It's not located on a number line. I to the third. Let's look at that. So as you look at this part right here, you would say 5I times negative 2I. So that would be a negative 10, and we would have I squared times another I, right? I to the third would be I squared times another I. So I squared is negative 1 times negative 10 is positive 10, and then you have that I left over. Well, try 12 on your own. Take 10, 20 seconds here and try number 12, see what you get. 12 no, 12 would be 20 would be 20, right? 12 is 12. Oh, the answer. Okay, I'm sorry. Well, I'm sorry. So you would get negative 20 I squared, and I squared is negative 1. You would switch the sign then to positive 20. Okay. Let's try a couple examples that are slightly more challenging. We do want to do the work towards the other sheet as well. These are binomials. Question, Alex? Yes. So we will FOIL. Negative 2. Now, when you FOIL, how many terms are you used to coming up with in the end? 3. You do not come up with 3 here. You only come up with 2. Negative 2 times 4 is negative 8. Negative 2 times I is negative 2I. Negative I times 4 is negative 4I. And negative I times positive I will write as negative I squared for the time being. So what do I get if I square a negative, or if I square I get negative 1. So this becomes a plus 1 right there is what that becomes. So I'd have a negative 7 minus a 6I. So that's how you FOIL them. They kind of threw an odd one into this problem with number 15, but we just multiply the two together out front first before we distribute them. And what is 21I squared? Negative 21 times negative 8 minus 6I. Negative 21 times negative 8 would be a 168. And negative 21 times a negative 6 would be a positive 126I. Now, I'm going to allow you guys to take about 10 minutes and work on the remaining part of the front and back before we move on to the second worksheet. The second worksheet is slightly different. It's actually probably, it's no more difficult than this. But let's take a break. You guys can look at that. If you guys could remind me to start the recording again, that'd be okay. You guys, let's look at this piece real quick. The second sheet talks about rationalizing imaginary denominators, and you cannot have an imaginary number in a denominator. And it's very easy to get rid of. You see you have 2 over 8i. What we can do is multiply the top and the bottom by I. If we multiply the top and the bottom by I, what do you get on the top? Over -8. That can be simplified to -I over 4. Right? Okay? So I think that really flows through with the rest of them. Somebody asked, well, can you do that with every single one? No. Look at number 6. 6 is not much more difficult. It's pretty much the same, slight twist. Again, we will multiply the top and bottom by I. Not always. You'll see in the next example. So you'll be able to tell the difference. You multiply top and bottom by I. What do you get in the top right now? 6i minus 8. Very good. What do you get in the bottom? A -9. Now, you don't leave it in that form. It needs to be a plus bi. You need a real part and imaginary part. So I will take my real part, which is -8 over -9, plus my imaginary part, which is 6i over -9. So you need to divide both pieces. Yep, so you would have +8/9. And then what does 6i over -9 reduce to? Right, minus 2i over 3. Yep. So again, we just multiply top and bottom by I, but you have to divide it by the bottom. And, it's equivalent in terms of its value, but it's more useful if it looks like that. We'll use that later on. And then to get to Taylor's point, well, what do we do if you don't multiply just by I? Well, if you look at 13 on the back, 13 is an example where you don't multiply just by I. Let me show you what you do multiply by. If you multiply the bottom by I, you can see that it will get rid of the first I, but what about the second piece? You'll end up with a -8i, and that doesn't help us, does it? So we have to multiply by something else. Let me show you a trick. Don't write this down. X plus 3 times x minus 3 is equal to x squared plus 3x minus 3x. Those go away. Minus 9. See how the middles go away? These are called conjugates. Conjugates are binomials that have the exact same terms, except one is a positive, one is a negative. So if we multiply the top and the bottom by the conjugate of the denominator, we are going to be able to free up, or we're going to be able to get rid of our i's. So we have a -8 plus 5i over a -8 plus 5i. That's the conjugate. It's the same as the bottom. I've just changed the minus sign to a plus sign. That will accomplish what we need to do. What's going to be in the numerator? -8 plus 5i. Denominator, what's -8 times -8? 64. What's -8 times positive 5i? -40i. Then I have -5i times -8, which is positive 40i. And then I have negative 5i times positive 5i plus 25. What happens to your 40i's? They go away. And so you're just left with what on the bottom? 64 plus 25, which is 89. And I need to divide both pieces in the top by 89, so it's negative 8 over 89 plus 5i over 89. So on these, you can see that you're going to multiply by the conjugate to get rid of I in the denominator. We don't want the imaginary portion in the denominator, so we do that. That's my final answer. Does that make sense? Okay, so what you see right now, that is what you're going to be doing out of the book. Shorter assignment on Monday. You don't have to finish this entire thing right now, but you do need to do a good enough job so that on Monday you can work through it. And if you need to go on your smartphone or if you need them to bring up the YouTube video, you can to watch it again so you see if you can understand it. This is what you will work on Monday, but you'll have an additional assignment out of the book instead.